John Cunningham here. I've completed my 8-bit breadboard computer inspired by Ben Eater's 8-bit breadboard computer kit, and what I've built here is pretty similar to what he did in his videos, although I've made a few minor changes. As you can see, the blue LEDs are super bright. I've tried to dim them down a little bit by having some more resistive resistors on them compared to the other ones, since they're so much brighter. I've used the 220 ohms for most of the LEDs, but the blue ones I put 1000 ohms on. And they're still kind of too bright to show up really well in the video, unfortunately. But we're just gonna work through that here. So basically, the program I've made here, here's my program, which I'll kind of explain later. One different thing I did was I've got a reset control pin, control output, so that when I cycle through my instructions in the EEPROM, I've got a reset, so that at the end of my instruction, I just have a one line that's all zeros and then the reset, and so it automatically ends the cycle programmatically. That way I don't have to count up to 8 every time, or however many times you've got in there. Also, I didn't do the counter way that he did, so I kind of simplified it to where I didn't have to use that extra IC here that counts the T cycles. What else? I removed my halt control bit and just used that for the flag in. I didn't really see the point of having a halt, because I can basically have a command, like a do nothing command, or if I want to stop the program, instead of just halting it completely, I can just put it into a loop where it just kind of sits there and loops into nothing. So that saved me a control bit, which I was able to use as my flag register, which I needed because I already used this as the reset. So other than that, I've got a hexadecimal display rather than a binary, or rather than a decimal display, which is a little simpler to construct. And the other thing I'll say, I did not use an Arduino at all. I programmed everything just with dip switches, and because I didn't have to do a BCD decimal display, it made it a little bit easier to do the display EEPROM, which I kind of explained in a previous video. And I'd kind of come that far and still hadn't used the Arduino, so I just said, you know, I'm just gonna program all this out manually, which I did, and it wasn't too bad until I got to the flag register. And then since I've got two different flags, the carry and the 0, so I had to program 3 extra instructions for each instruction that I've already programmed. So that wasn't too bad, and I've got my little programming set up here, where, you know, maybe once I added the flags register, it took me an extra 45 minutes or so to sit there and add all the instructions that I'd previously added. So what I'm doing right now is I've got a program similar to one that I think Ben Eater did in his video. I'll speed it up a little bit so it cycles back around. It basically just counts. I'll cycle it around so you can see. So it just counts one at a time from 0 all the way up to its maximum ability, which is 256, since we got an 8-bit data. I don't know what you'd call it. An 8-bit data register, I guess. I guess the main limitation of the computer is that there's an 8-bit bus, so it's an 8-bit computer. The registers are 8-bit, so you really can't do much beyond 256. Although I guess you could, since we got memory, maybe you could organize a way to do numbers higher than 256 by using the RAM. But for now, we got this program. It counts one at a time. I'll speed it up a little bit. Counts one at a time all the way up to 256, and then once it gets there, it subtracts back down. And then once it gets to the bottom, it adds 1 to its increment. As you can see, the B register changed from 1 to 2, so now it's counting by 2 all the way up. And it gets to the end. I'll slow it down so you can see it reverse. And again, I got a hexadecimal here, so it's, FF is 255, which is the max. Once it gets beyond that, the carry flag sets, and then it didn't reverse. Oh, maybe that's not working right now. That's embarrassing. Well, it was working earlier, and I think I changed something. I may have rewritten my code to experiment. Okay, so it counts by I did increment the counter, so it's counting by 3 now. C3, 6, 9, C, F. One of the biggest issues I've had with this has been hex inverters. For some reason, my hex inverters would work and then not work. And I really couldn't figure out why. Once I decided I think maybe it's the output of the EEPROM doesn't have a voltage output in the good enough range for the hex inverter, the 74 LS04, to operate properly, because sometimes my hex inverters wouldn't invert, and that was a source of a lot of frustration when I was building this. So what I did was I just used a NAND gate, the 74 LS00. I don't know if you can see the print on there, but there's 2 NAND gates I ended up using. I used one there and one there. So all of my control bits that I need to invert, when I was running through the hex inverters, sometimes they just wouldn't invert, and I could never figure out why. Sometimes they would, sometimes they wouldn't. And I gradually converted all of my inverted control lines to invert through a NAND gate. So what you do is you just NAND the signal with itself, and then the output is inverted. And that's been a lot more reliable for me than the hex inverters. It was crazy, I had everything kind of working, and then one thing would stop working, and I figured out it was the hex inverter, so I would move that one signal to a NAND gate inversion, and as soon as I did that, something else would quit working. And gradually I just phased out the hex inverters completely, because it was just problem after problem. So anyway, eventually I got this working most of the way, although I still seem to have some kind of problem with it not reversing reversing into subtract. Let's see, 6, 7, it's counting now by B, which is 11. Let's see, now it's counting by C, which is 12. It's just counting, it's not reversing. Okay, well, I think because I was having problems earlier, I simplified my program, and I forgot to change it back. I was having problems earlier with the B register would input not what I was trying to load, but what was in the instruction register. Because the previous cycle, the instruction register was outputting, and I guess the B register would be inputting too soon, and I figured out that it was because my inverted clock signal was sometimes not inverted, and it was because of the hex inverter. Again, the hex inverter. So what I ended up doing was I got my oscilloscope out here and got to where I could see the signal of the B. Once I sped it up really fast, you could see where the B input would go low, and the instruction register I'm not sure if that one's inverted or not, but you can see how the signals overlapped. And what it's supposed to do is stagger, so as soon as one signal ends, then the next one begins. And on the oscilloscope, you could see that very clearly. But then sometimes at particular speeds, it was like they would happen at the same time instead of sequentially. And it turned out that once I fixed my inverted clock signal to run through a NAND gate instead of a hex inverter, then it was a lot more consistently staggered like it was supposed to. Anyway, I feel like I've gone on and on here, but basically pretty much completed this project as far as Ben Eater's videos went. Here's my program that I'll kind of explain how this works here. I got a load immediate, so it loads 1. Then I store that value into F, which is the bottom of the memory space. Output, I add that value to itself, and then if that value is greater than 256, we jump out of the loop, otherwise we repeat. So it'll go through the loop all the way up to 256, one at a time. It'll jump out, then it'll go into this loop where it subtracts, so it kind of undoes everything that it did, one at a time. Once it gets to 0, I got to jump if 0, then it jumps out of the loop, otherwise it repeats. So it goes through here until it counts down back to 0, then it jumps out. Then I load 1, and then I add the value of F, which we'd originally set as 1, to that one I loaded, so now it becomes incremented. And then I store that value back to F, and then I repeat unless we've gone all the way back to 0, and then we repeat the whole thing. I'm not really sure if this part of the program was necessary, that jump instruction. I can't remember, but basically it'll count by ones all the way up to 255, and then subtract all the way down, and then it'll count by 2s and do it again, and then it'll count by 3s, and then 4s, and then 5s, and eventually it'll get all the way back to 256, which is 0, and then repeat. So I'm going to end this here now. I want to fix my program and then demonstrate it running properly because it's not running right. And I also want to make a video showing the oscilloscope and showing how I was able to see the timing of the different signals using the oscilloscope, and that was helpful for me to figure out what was wrong with my program and why it wasn't working right. Thanks for watching, and I'll make another video here soon.